In today's video, we're going to be talking about the power rule for derivatives. In my Intro to Derivatives video, I used this equation to solve every single derivative problem. And it's really long and sucks. But fortunately, we have some things such as the power rule that can make derivatives really easy to solve. And we're going to talk about arguably the most common one, the power rule, today. The power rule states that if we're trying to find the derivative for any function raised to the n power, so whatever power you have, this is equal to n times x to the n minus 1 power. So what's actually happening is we pull down whatever our original exponent was to the front, and then we subtract 1 from the exponent to find the derivative. And let's do some examples to make this a little bit easier to understand. Our first example will be something pretty simple. We want to find the derivative of x squared. What is this equal to? This function is screaming for us to use power rule. All we have is an x raised to a power, so to find the derivative, we can just use the power rule. Let's apply our power rule to this function. First of all, what we have to do is bring down our 2 to the front, our n value. And then we just need to subtract 1 from 2. So this now turns into 2, which has been brought down to the front, x to the 2 minus 1 power. Of course, this is now equal to 2x to the first power. But remember, anything to the first power is just itself, so we don't even have to write the first power. This is just implied. So the derivative of x squared is just 2x. Let's do some more difficult examples for different situations, because the power rule is a lot more useful than you might think. And of course, the rule will be here in case you ever need it. Example number 2. Let's find the derivative of 8x to the 4th power. What is this derivative? Now, the only real difference between this problem and this problem is that we have a coefficient already. So what do we do there? Well, we still pull down our power to the front. So we're going to put this 4 here, and we still subtract 1 from 4. So what happens when we pull this 4 down to the front? Well, we just multiplied this 4 by our old coefficient 8. So this is now equal to 4 times 8 x to the 4 minus 1 power. Simplifying this down, 4 times 8 is equal to 32 times x, and then 4 minus 1 is just 3. So the derivative of 8x to the 4th is 32x cubed. Pretty simple, right? Not too much harder than the last example. Let's do some examples where you may not think to use the power rule right away. In this example, we have the function square root of x. What is the derivative of this function? Now you may be asking me, hey, Callum, that's not a power, that's a square root. How are we going to apply the power rule to a square root? Well, here's a neat little thing in math that'll actually help you a lot in Calculus 1. The square root of a function, say x like we have here, is the same as x to the 1/2 power. So let's convert our function into x to the 1/2 power. This is equal to d dx of x to the 1/2 power. And now you can see it's pretty easy to apply the power rule. Now we just need to bring down the 1/2 and subtract 1 from it. So this now turns into 1/2 times x to the 1/2 minus 1 power, which is just equal to negative 1/2. So you could leave it in this form and this would be a correct answer, but I'm going to simplify this down a little bit more and we're going to use a little bit of algebra that you may not remember. A negative power will put whatever function you're raising it to in the denominator. So this function can be simplified down into 1 divided by 2x to the 1/2 power. And since the 1/2 power is the same as the square root of x, I just think it looks nicer if we write 1 divided by 2 square root of x. I just think that looks a little nicer. So this is your most simplified answer, but most teachers will still accept this. In this example, we have the function 1 divided by x. What is the derivative of this function? Now, once again, you may be asking, there's no power in this function. How are we going to use the power rule for a function that has no power attached to it? And once again, just like our square root, we actually do have a power attached to it. Remember, just a minute ago, we talked about how negative powers puts whatever you're raising it to in the denominator. So this is actually equivalent to x to the negative first power. That would just put x in the denominator and have it be 1 divided by x. These two are equivalent. Once again, we can easily use the power rule here. Let's bring our negative 1 to the front, as such, and then subtract 1 from it. So this now turns into negative x. We could write a 1 here, but it's not necessary. to the 1 minus 1 power, which is equal to negative 2. And once again, with a negative exponent, we can bring this down to the bottom and our exponent turns positive. So this answer is negative 1 divided by x squared. And that is the derivative of 1 divided by x. We're going to do one more example in this little space we have here, and that'll be it for this video. The power rule is pretty simple, but extremely helpful. So our last example for this video will be this. We want to find the derivative of 2x. Now you may be saying, hey, that looks pretty simple like some of the ones we did up here, but I want you to notice that we don't have a power here, or it doesn't look like it at least. But once again, there is a power right here. We have a 1 right there. We don't have to write the 1, but there is a 1 there as it's implied. We don't have to write the 1. So let's apply the power rule here. If we bring this 1 down to the front and then subtract 1, we get our new equation, which is 1, hold on, let me write that in green, 1 times 2 x to the 1 minus 1 power, 1 minus 1. Now, as you hopefully know, 1 minus 1, of course, is equal to 0. So this derivative is equal to, and of course 1 times 2 is just 2. This is equal to 2x to the 0th power. So what is the derivative? Well, anything to the 0th power is just equal to 1. And since x is being raised to the 0th power, it's just equal to 1, which means we can cancel out. So the derivative of 2x is just equal to 2. This is a nice little trick to know. If you have any coefficient being multiplied by just x or just y or whatever variable you're using, the derivative is just whatever the coefficient is. And I wanted to show you that with this example. I hope you enjoyed this video. The power rule is very simple but very powerful and can help making these problems so much easier. Consider subscribing if you need more Calculus 1 help, and check out the Calculus 1 playlist, which is linked here. I'll see you guys in the next lesson.